Okay, I'm back. Let's do 1 point, 3 point, perfect cubes. Let me show you the procedure for that and how you can use that. So the first thing I'm going to do is put the horizon line about, I don't know, 4 inches down. That's plenty of space. It looks about like 4. It's close enough. And we'll just bring that line all the way over to the horizon line here. Okay. Then the center of vision will be right in the center at 12. We'll put that right in at 12 here. There we go. Line that up and in. Okay, so we'll bring down our center vision point. So the goal of this lesson is to demonstrate how to get, you've seen in now 3-point perspective, really 2-point, 3-point, how to get 45-degree measuring points, how to swing and then project or construct 90 and then project 45 to get those measuring points. Here it's a little bit easier to get the actual 2 45-degree measuring points that you need. Now for this drawing, let's do a head tilt at 32 degrees. So I'll take my protractor here and we'll set it in at 32 along here. So I'm at 30 and then 1 and then 1 and 2 here, right there. I'll put a little dot so I can project through and over. Right there, that gives us our head tilt, 32. Let's draw a nice line over, pointed arrow. So it's going to be 32 degrees bird's eye view of a head tilt. Okay, so now I'm just going to take my 90-degree angle here to find my vertical station point and my vertical vanishing point and try to keep it on the paper. So the best way I can do that, excuse me, we know that relationship is at 90, so I'll take my 90-degree angle and work it where I can keep it on the paper. Right here is nice. Shoot down, right in through there. So that's my vertical vanishing point now down here at the bottom, VVP. And of course over here is my vertical station point, which is our little bitty person here. I won't draw it this time. And of course here's our eye level now coming across here, right in through there. Here's our new eye level. Here's our horizon line. Here's our eye level here. We can label that EL horizon line over here. This becomes the horizon line center point, but more importantly, it's also our vanishing point, center of vision in through here. And remember, this is a 90-degree relationship right in through there. Important, always important to know that. Okay, let's project now our cone at 30 and 30, right, to give us our 60-degree total cone that we can work in. So we project 30 outward here, right in through there. So it's nice. Come through here. Right through there along our center of vision to project our cone. Here and here. Laying this down. And over. There we go. Alright, coming through. Right through there. Okay, so we've got our cone demarcated, and then we'll go ahead and throw out, I'll use our compass and throw out our cone proper. Here and here. We'll line that up to get our radius, and there we go. Throw out our 60-degree cone. I'll make that nice and obvious so we can see that. We can kind of compose in that. There we go. Okay, so to start out, we need a ground station point like we have in 1-point perspective. And remember, that's along the center of vision. Well, we don't have it, and how do we get it? Well, it's pretty easy. We're going to take our vertical station point, the distance of our vanishing point and our vertical station point, and we're going to swing it, right? We're going to swing it over to our center of vision to give us our ground station point so we can direct a 45-degree. Well, the easiest way to do that is just demarcate it on a piece of scratch paper. So I'll do that now. So I'll line it up on this line. So from our vanishing point to our vertical station point, these two areas, okay, they align now on our center of vision, so we swing them on over, and you're going to find that our ground station point will be right there. So we'll demarcate that nice big red, relatively big dot through there, and I'll label that ground station point right here. So we need a 45-degree projection. Easy enough, right? So we take our triangle and we project at 45, lining it up on the center of vision. Make sure it's your 45-degree angle that's being projected. And we'll project it here and over. Bingo. Kind of draw through, show you an arrow right in through there. There's the, on the horizon line where that dot is placed, where we know we get our 45-degree measuring point. Okay, now we're going to need another one. This is going to take care of bottom planes and top planes of our perfect box. That boxes that we're going to draw in 1.3 point. We need another one for our side planes. Okay, our front planes, our back planes. So bear with me now, look down here. The vertical vanishing point is what we're going to use from. We're going to swing our vertical station point, and we're going to swing it down and meet our vertical vanishing point here along this 90-degree relationship from the center of vision. Let me demonstrate so you can see it, since it's a visual problem. So look down here. So from the VVP right here, we bring, and I'm just going to bring a straight line all the way across, all the way to the end here. So this becomes a 90-degree relationship right through there. Make sure you know that 90 degrees here, right, and 90 degrees down here. So now we're going to swing this distance over to here. I think I've got enough room. I think I've planned out enough room to put on the piece of paper, hopefully. Well, we're going to find out. Let's see. Okay. So if you're like me and you use your scratch paper for mini Marc, try to color code it sometimes. Sometimes I get them wrong and I have to do them over. So we just line up our scratch paper along our vertical station point here, and then our VVP down here. We'll make a nice demarcation with a blue line here and here. And then watch, we're just going to swing it on over to here. Right, I'll demarcate this back in red. So we line that up along our new construction line here. Put a nice dot so you can see it right through there, way down here, pretty far away. That's our next 45-degree measuring point. And I'll demonstrate now why and how we use them to get perfect cubes. Remember, that's what we're going for. Perfect cubes in 1 point, 3 point perspective. So let's start that now. So let's lay down. We could scale out even now if we wanted to, but I won't scale. Excuse me. We'll know that these are perfect cubes. All right, so let's lay down a line here along. We'll keep it in our cone. We'll make it, I don't know, let's make it 2 inches long, but we'll put it off center a little bit. So I'll start from the 12 to the 14. That'll be 2 inches, but it's a little off center from our center of vision. Make it more interesting. Okay. Then we're going to project from, and I'm going to come in now a little bit so we can see this a little bit better. Try to get this all in, so I'll have to stay out a little bit. Let's see what's going to be best. I'll bring that up. Yeah, we can start to get, excuse me, get all that in. There we go. Okay, so now we're good. So now I'm going to project diminishment from this line back to our 1 point vanishing point. Okay? We're in 1.3 point. See if I can get through this lesson without breaking a pencil. Probably not. Maybe I should just go ahead and break it so that way we just get it over with, but we'll see. We'll try. All right, so now we just have a rate of diminishment back to the vanishing point, but we don't have a finishing distance for 45 degrees. Well, we know how to do that in 1 point. So from this corner now back to our 45-degree measuring point, and we have now a demarcation to say, boom, stop. Right here, this goes back to the 45. We can stop there along that diminishment line, and now we know where to project our horizontal line over here. There we go, right through. All right, so I'll darken this in a little bit. So now we have our plane. This could be a way to do perfect tile flooring in 1 point as well. But we're doing a perfect box right now. All right, so now we have a perfect box, or the ground plane of a box in 1 point. We really don't have any 3 point perspective going on. It's really just a 1 point form. Well, let's do that now. So let's bring up our verticals. Remember, from our vertical vanishing point right here up, and we'll start with our corners here. I'm just going to overdraw a little bit classically to give us plenty of space to work with there. And also roughly right in through here. Okay, we're good to go. So now what? Well, we have to go from this corner, remember? from our vertical, from our 45-degree measuring point way down here. Make sure you're looking right there. There it is. Up and through this point to bisect that line. Really not too hard, just kind of a long angle. So we'll set up our ruler here. From this corner, it's got to come through this corner. It's got to be 45 degrees. That's in perspective right there through this line, this corner, right through there. Where it touches right there, okay? That's our 45 degrees in perspective, 1-point perspective for our box. And of course we know when it touches there, we know where and how to bring it over right there for our box. Now remember, we're in 3-point perspective at a 32-degree head tilt. So we're 32 degrees looking down on a flat, perfect, level 1-point box. It is not tilted up. Rule number 3 in perspective, remember, is the rule of incline, where we bring the vanishing point up. Here we're not, because our head's tilted down. We brought the horizon line down to make a new eye line. Okay, so now we've got everything we need. We can project space back to the VP here. How easy is this? Back to the VP here. Okay, so we've got that ended. Now we need to bring these corners up. So from the vertical vanishing point, we bring our corners up here, touch our diminishment line. Through here, touch our diminishment line right in through there. We're good to go. Now we bring our corners up and over. There we go. All right. There we go. And now we're going to have our box here, our top plane, and there we go. Now we've got a perfect measured cube. I wouldn't say necessarily measured, but we know all sides are equal. That's what I meant to say. So all sides are equal. Now if I said that 2 inches, the 2 inches that I started with, if each one of those equaled a foot, that would be a 2-foot box. Or if I wanted a really gigantic scale, like a building, 1 inch could equal 30 feet, and that would be 60 feet. It's a perfect cube. That'd be 60 feet wide, 60 feet tall even. So we could really make something in scale. And the scale would depend on what you give it. And you adjust your figures accordingly as you want. So there you go. There's your 1-point, 3-point perfect cube. Let's do one more next to it. Maybe 1 or 2 more. Just 3 would be nice. So let's do one down here, maybe a little bit smaller. So maybe I'll just put it about this length. I just made it a little bit longer on the right side than I did the left. Okay, right in through there. And now I'm going to project diminishment back to our VP. If I go a little fast, slow me down. Through here. Now I need to know where I cut off the end of the plane, of the ground plane of the box. And the only way I can do that is come through this corner over to our 45-degree measuring point. Right in through there, up and over. Look how far over that is. Pretty nice. There we go. So we're getting further outside the cone. So we're going to get a little bit longer space here as we're looking further, closer down. It's a little bit closer to us. That's what perspective gives you. And then, of course, you could freehand sketch from these later on and to give yourself perfect cubes in freehand sketching. There we go. So again, we knew where to stop here along the diminishment line here. And of course that gives us the place where we bring it over horizontal. Now we need our verticals to come up. So let's bring our verticals up from our vertical vanishing point up to, we'll just start with these 2 corners here. And I'll overdraw a little bit there. And lining up here a little bit, overdraw through there. Then of course from here is our point that we're going to project our 45 from. Back from our 45-degree measuring point from our bottom vertical vanishing point. Remember that we got over here, that we swung over right through this corner here. There we go, and through and up, and then we touch right there. Bingo, that's where we know where to stop. Right in through there. I'll just draw it over so we can see that. There was our 45-degree, right in through there. So we knew where to stop, and now we know where to bring our horizontal over to here. Horizontal comes over, stops at our vertical here. Bingo, right there. We're good to go there. Okay. And we'll come down. We'll come down. Tighten that in, darken that in, excuse me, in a little bit. And now we're going to just project our diminishment back to the vanishing point here and here, back to our VP there and there, okay? And we're going to bring up these verticals in our corners here. If I go too fast, slow me down. From our vertical vanishing point, we'll project up our distance here to our diminishment line, and also here to our diminishment line. There and there, there we go. We've touched and we're ready to bring over our horizontal right about there. There they go. A little thick on that one side. And then where they back into that, where they touch, I'll darken that in. And I'll darken this in. Bingo. And now we've got two perfect cubes. One's just bigger than the other. I'm going to take my eraser and kind of lighten up the line weight inside these boxes here so you can see that a little bit clearer. We want to make them a little transparent, more transparent-ish, so we can see what's going on structurally. That's the important part of this, is to see all that, the goings on of that structurally. There we go. Okay. Bingo. And so we now have two perfect cubes in 3-point, 1 point. All right, let's put one more over here to the side and really get this, reinforce this procedure down. Once you get, again, once you get your setup, you're good to go. Really not too hard at all. So let's put one, at least I don't think it is. Let's put one over, let's put one about right here. We'll still stay in the cone. We're going to get some distortion because we're getting further. Remember, especially in 3-point, we've got a 60-degree cone, really about a 30-degree cone, which would be in here, which would be 15 and 15 projected over, is probably even better for less distortion, but it is what it is. And I like a little distortion. So there's our bottom line for our box. Now we're going to project our diminishment back to our vanishing point here and here. And of course, now we need to know where we cut off. I'm going to sharpen up my pencil a little bit. And so we need to go back to our 45-degree measuring point, right, from this corner over to our 45-degree measuring point, through, right in through there, where they touch, right there. That's where we know to stop. And we can bring our horizontal line over. And of course you could also have a 45-degree measuring point over here for the same way. You could do it the opposite way. Either way is fine. Of course you could bring this one, you could put your vertical station point here, you could have flapped it over here and then brought this one over if you wanted to as well. Most of the time I just do it to the right because I was taught that way and I just got used to it. Okay, so we need verticality coming from our vertical vanishing point when we're in 3-point. So we'll come up and I'll overdraw a little bit. Same thing on this side. Come up and I'll overdraw a little bit there and there. Okay. And then from our corner here, we need 45-degree measuring point down below. Remember that. Need to overdraw a little bit more. We're gonna need a little bit more here. Excuse me. There we go. Should be enough. Okay, so from our 45-degree measuring point through this corner of our box, that's got to be 45 degrees in perspective coming over through here. That's pretty good alignment right through there, and I can bring it up and over. There it is. Bingo. There's our 45 degrees. We touch right there, and then we can bring over now. We know where to stop horizontally. Nice. Tells us what to do. Even if you didn't understand all the ways that we got this, if you can do the setup and the procedure, you can get it down and you kind of, that's how I learned it. I learned the procedure from my professors in LA, from Gary Meyer at Art Center, and then it wasn't until later on that I really learned why, and why it was important as I got more mature. So now we just project back to our VP here from our corner, right? Same thing here from our corner. We're good to go there. Then we know to bring up verticals from each corner here. We're just about done, right? So from that point up, touch here. Okay, and from this point here, bingo, touch right there. And we know where to end our back box. Right there, they line up pretty well, not bad. There we go. And we've got it. So I'll just darken it in and wrap it up here and here. Okay, and there. Look at those perfect boxes in 1-point, 3-point. We've also done it now in just 3-point, or you could say 3-point is another fancy way of saying 2-point, 3-point. It's just we have, nobody really says 2-point, 3-point, but we have to make that distinction in 1-point, 3-point. I think that's pretty important. So there we go. We have our perfect cubes now in 1-point, 3-point. And remember, we have our head tilt at 32 degrees in bird's eye view. So I think it's important to realize that in order to understand these, the swinging happens from the vanishing point to the vertical station point. That swings over right to here. So I took a piece of scratch paper and just took that measurement and brought it over. It lines up on the center vision line. That gets us this 45-degree projection, okay, for these bottom planes. But the top planes are in 3-point. We need a projection too as well. So we took from the vertical station point, vertical vanishing point down below. We projected this distance along here, or you can think of it as swinging over, and that gives us way down here the projection for planes coming through these corners, and you have your perfect 1-point, 3-point cubes. Now you can do the same thing in also if you wanted to in worm's eye view. I won't do that. We'll go on to a more complex arrangement, probably going on to a room now with tile floors and maybe some boxes and things. There's some little figures too as well to get that procedure down. So there you go. That's 1-point, 3-point, and we could turn it upside down. Let me take the tape off this so you can see it. Same thing happens here, right? So there we go as well. So you have your setup here, and nothing's really changed. Just know that, just know what corners you need to come through. I think otherwise you'd be good to go there. Okay, there you go. All right, I'll see you next time. And we'll, with formal perspective, we'll move on to, again, a 3-point room. And we'll put 3-point forms and 1-point forms. We'll probably use 45-degree measuring points for all our forms too as well. So some can be perfect box-like forms, and some can be, we don't have to use it for use every measuring point for everything as well. All right. Okay, I'll see you then. Take it easy. Bye-bye.